Hello, welcome to my channel. In today's video we want to solve another series of challenge which read b square minus a is equals to 73, a square minus b is equals to 73. So we are finding the possible value of a, b and a rather. So please, if you are new here, kindly subscribe, and by the time you're done subscribing, please don't forget to turn on the notification button so that you get notified anytime I drop videos on mathematics. So let's see how we can solve this nice problem. So we can simply say solution. Then we are having b square minus a is equals to 73, a square minus b is equals to 73. So since both of them are equals to 73, we can simply rewrite this by saying b square minus a is also equals to a square minus b, because we said since this and this are equal. So if we are having this, we can simply bring this to the left hand side. So we can rearrange this by saying b square plus b is equals to a square plus a. Okay, since we've done this, we are not having this. So what are we simply going to do from here? We are having a b as a common factor, right? So we can say b square plus b is equals to a square plus a. So if we are not having this, b is at one side, then a is at one side. Okay, now we are having square, right? We are having squares. So let's put the square value on one side and put the values without having square on the other side. So we can simply write this to be b minus a is equals to a square minus b square. So this is now a new problem, which implies, coming here, we can further say b minus a is equals to a square minus b square, right? Recall from your basic mathematics rule, if you are having a square minus b square, the difference of two squares is also equals to a plus b, close bracket, open bracket, a minus b. So since we are having this, the difference of square a square minus b square is equals to open bracket a plus b, close bracket, times open bracket a minus b. So if we do that, we can say our b minus a is also equals to open bracket a plus b, close bracket, a minus b, close bracket. Since we are not having this, what are we simply going to do? Let's bring the whole of this to the left hand side. So if we do that, we are having b minus a minus, you can put a bracket here to differentiate it, open bracket, minus open bracket a times plus b times a minus b, all equals to 0. So we are not having this. So this is what we are not having. So we want to make this look similar to this. Here we are having b minus a, here we are having a minus b. So what are we simply going to do? We can multiply both sides of the equation with a negative sign. So multiply here with a negative sign times here with a negative sign also. So we simply have, so we can put a big bracket here also to differentiate it. We are having this one to be equals to 0. So if you open the bracket with the negative sign, we can simply have this to be minus b plus a. This sign, this is going to turn to positive because this sign is affecting these two. So to put this to multiply, this is going to turn to a positive sign plus of a plus b times a minus b is equals to, no, we can't have a negative 0, so we just put 0 there. Okay, we are not having this, so we can write this to be a minus b, we can put a bracket plus open bracket a plus b, close bracket, a minus b is equals to 0. So this is what I'm trying to say. Let's make this to look alike with this. So now we are now having a minus b, a minus b. So we can simply factor. So if we factor, we are going to have a minus b, open brackets, we are having this, we are going to have one here plus a plus b, close bracket, all equals to 0. Okay, this is what we are not having. Since we've gotten this, we can equate this to be 0, then equate this to be 0. So we simply have our a minus b is equals to 0. Therefore a is equals to b. So since we've done this, we can say 1 plus a plus b is also equals to 0. So therefore, making a the subject formula, I can say a is equals to minus b minus 1, because we said let's bring this and this to the right hand side of the equation. So we are having 1 plus a plus b is equals to 0. So our a is equals to minus b minus 1. So let's simply come this other side and solve for that. So if we've gotten this, we are now having a is equals to b. So let's differentiate it from this other ones. A is equals to b, and we are now having a is equals to minus b minus 1. Okay, so we've done this. What then is our next step? So we said our a square minus b is equals to 73. Okay, a square minus b is equals to 73. Therefore our a is equals to b. So you can simply say b square minus b is equals to 73. So we've gotten this, we can say b square minus b minus 73 is equals to 0. So we are now having it as a quadratic equation. So if we want to solve this, actually we can't use the factorization method, because if we solve this, it's going to lead us, we are going to have we are going to have it in radical forms. So we can't use the factorization method to solve this. So how are we going to solve this? We can only solve this using the formula method, which says, since the identities are now b, you can say b is equals to minus b plus or minus the root of b square minus 4ac over 2a. So we are not having this. So since we're having this, what is your a? So we can say b is equals to minus 1 close bracket plus or minus the root of negative 1 all square minus 4 times 1 times minus 73 close brackets, all divided by 2. 2 times 1 is going to give us 2. So this is what we are not having. So let's move further to solve. Since we are not having this, we can simplify further by saying b is equals to minus times minus is going to give us plus. We are having positive 1 plus or minus the root. This one is going to turn to a positive 1. Then this, we are having a negative sign here. 44 times 1 times 73 times negative 73 is going to give us a negative 293. I believe 293, and negative 293 times negative value is going to give us a positive value. So we are having plus of 292 or divide by 2. So if you sum them up, therefore our b is equals to 1 plus or minus the root of 293 or divide by 2. As you can see here, we are having two values. So therefore our b is equals to 1 minus root of 293 divided by 2, and b is also equals to 1 plus root of 293 or divide by 2. Okay, since we've gotten this, therefore we can say, I will say a is equals to b. Therefore our a is also equals to 1 minus root of 293 divided by 2, and a is also equals to 1 plus root of 293 or divide by 2. So this is our first value for a and b. So let's move on to the second case where we will say a is equals to minus b minus 1. Okay, we are now having this. A is equals to minus b minus 1. And recall, our other equation says we are having b square minus a is equals to 73, right? B square minus a is equals to 73. And recall we said A is equals to minus B minus 1. So we can simply further and say B square minus open bracket minus B minus 1 close bracket is equals to 73. So in the place of A, we substitute minus B minus 1. So we are now having B square minus open bracket minus B minus 1 close bracket is equal to 73. So if we further break this down, we can have this to be B square plus B plus 1 is equals to 73. So let's come this way, which implies we can have this to be B square plus B plus 1. So if you bring this to this other side, we're having minus 73 is equals to 0. So since we've done this, we can say B square plus B. So 1 minus 73 is going to give us a negative 72 is equals to 0. So since we've done this, so what are we simply going to do? So we can easily factorize this using we can solve this quadratic equation using the factorization method. So what are we going to do? We are going to think of two numbers. By the time we multiply those two numbers, we are going to have 72, and if we should subtract or add those two numbers, we are going to have a positive 1. So those two numbers are negative 8 and 9. So we are going to have negative 8 and 9. Therefore, if we solve this further, we can have B square minus 8b plus 9b minus 72 equals to 0. So this is what we are now having. So if we should put a bracket here, let's bring out the common factor. So the common factor between b square and minus 8b is b. So we can say b open bracket b minus 8 close bracket. The common factor here becomes positive 9, because b minus minus 8 all equals to 0. So furthermore, we can say b plus 9, we are having 9 here, times b minus 8 all equals to 0. So this is what we are now having. So if we come here, let's come this way. So we are now having b plus 9 times b minus 8 equals to 0. We can say b plus 9 is equals to 0 and b minus 8 is equals to 0. So therefore, we can say b is equals to minus 9 and b is equals to 8. B is equals to 8. So this is what we are now having. So b is equals to minus 9 and b is equals to 8. So since we've done this, so what are we simply going to do again? So recall I said a is equals to minus b minus 1. So when b is equals to minus 9, so you can say a is equals to minus 9 close bracket plus minus 1. Therefore, our a becomes this and this will turn to positive. So we are now having a 9 minus 1, which is equals to 8. So we're now having 8. We're now having 8 here. Okay, let's move on to this part. So we said when b is equals to 8, we can say a is equals to, what then is a? Minus 8 minus 1. So therefore our a is equals to minus 9. Therefore all the possible value of a and b, when a is equals to 1 minus root of 293 divided by 2, a is also equals to 1 plus root of 293 divided by 2. Now b is also equals to 1 minus root of 293 divided by 2, and we said b is also equals to 1 plus root of 293 divided by 2. So these are the first two values for a and b. Let's look at the other one. When b is equals to minus 9, a is equals to 8. When b is equals to 8, a is equals to minus 9. A is equals to minus 9. So let's try. Let's see whether the value of A's and B's are correct by substituting these two into our question. Recall, our question says B squared minus A is equals to 73. So when A is equals to when B is equals to 8, our A becomes negative 9. So we can say 8 squared minus open bracket minus 9 close bracket is equals to 73. So we can simply do this. 8 squared is going to give us 64 plus, so it's going to turn the positive sign, plus 9 is equals to 73. So we've done this. So 64 plus 9. What's 64 plus 9? 64 plus 9 is going to give us what? 73. So 73 is equals to 73. Therefore, the value of A and B's are correct. So if you substitute when B is equals to negative 9 and A is equals to 8, it's also going to give you the same value. And if you also substitute all these complex ones, this one's having radicals in this our question, it's also going to give us what? 73. So if you find this video useful and interesting, please don't forget to click on the subscription button and turn on the notification bell so that you get notified anytime I drop videos on maths. You can see at the end of the class we are able to look whether the value of A and B are correct by substituting it into this question, which is B squared minus A is equals to 73, and we find out that 73 is equals to 73. Therefore, all the possible value of A and B's are correct. And if you have not hit on the thumbs up button, please do well to do that before leaving. Thank you, and see you in my next video. God bless you, and Jesus loves you. Bye for now.